All right, hello CP Chem. Last time it seemed like the notes weren't working super well from the way I did it. So I'm gonna do it like this. I think you'll be able to hear and see a lot better. So today is either Wednesday or Thursday. I don't remember when you guys are doing this, but today you're learning kind of the foundation for calculations in chemistry, which is dimensional analysis. This may be the first time you have ever done this. So I'm going to try to do it like you've never learned it before. So the way I define dimensional analysis is basically just a series of ratios. I'm going to put a box around that, used to problem solve. A series of ratios used to problem solve. And these ratios that you're going to be using are just conversion factors. These are just conversion factors. And all conversion factors are based on 1. So some popular conversion factors that you may know would be something like 1 minute is 60 seconds, or 1 meter is 100 centimeters, or 1 yard is 3 feet. Those could be some popular conversion factors that you may know. And it doesn't matter which one's on the top, which one's on the bottom, but they are all, we'll write it down, based on the number 1. When you're doing dimensional analysis, you always show work. And as you're showing that work, the units will cancel out. And I usually like to just strike through to show that my units cancel out. You guys don't have to do that, but I like to say that units are like a breadcrumb trail. So units are our breadcrumb trail. Here's why. I think breadcrumbs, is that Hansel and Gretel? I think so. So they put the breadcrumbs down so they can find their way back. They can also help you find your way forward, because whatever unit you're starting with, you kind of start with on the next step. And if you know what you're trying to get to, you can use your units basically to get there if you understand them. So let's start out with something super basic, like how many, millimeters are in 2.5 kilometers. How many millimeters are in 2.5 kilometers? Would you do this with dimensional analysis? Most likely not. But we're doing something super easy. So I have 2.5 kilometers is what I'm starting with. If I have kilometers on the top of the first step, I have kilometers on the bottom of the next step. So 1 kilometer is, you can either skip straight to millimeters and do like 100,000. I like to use easier units. 1 kilometer is 1,000 meters, and I know that 1 meter is 1,000 millimeters. So you will multiply everything on the top and divide by the bottom. Kilometers cancels out, meters cancels out, leaving millimeters. So on my calculator, I would do 2.5 times 1,000. Oh, you can't see that. Times 1,000. And that gives me 2.5 million, or 2.5 times 10 to the 1, 2, 3, 4, 5, 6, which is what we would expect, millimeters, because that is how many places you would have to move the decimal. 2.5 times 10 to the 6 millimeters. So that's a little example. Let's do something a little bit more involved now. So this will be, we'll call this example 1. Let's call this example 2. What if I said, how many seconds are in 1.32 hours. So we did not talk about on the first one about sig digs. So let's talk about little steps. So let's do asterisk 1. I usually like to say start with the last number you are given. I would say 9 out of 10 times this works. So the last number I'm given is 1.32 hours. The next thing is the answer will have the same number of sig digs. The answer will have the same number of sig digs you start with. So on this question, I already know my answer is going to have 3 sig digs because this is what I measured. Sig digs are all about measuring something. Then I also like to say save the rate. So if you're given a rate in the problem, save it. It's like save the date, but save the rate. Save the dates are a little bit more exciting. I just got asked to be a best man at a wedding. I thought I'd aged out of that. You know, I'm getting older. I'm 37. But I got one more wedding at least next year, so that's kind of exciting. One more wedding where I get to spend a lot of my own money to buy a tux and do all that stuff. But hey, you know, it's for one of my friends, so it's worth it. But anyway, save the rate. Save the rate. And you'll see what that means on another example. And then lastly, you multiply everything on the top, then divide by everything on the bottom. So here's our example. How many seconds are in 1.32 hours? So I'm going to start out with 1.32 hours. If I have hours on the top of the first step, I put hours in the bottom of the second step because the units are my breadcrumb trail. So 1 hour is 60 minutes. And I know that if I have minutes on the top, I have to have minutes in the bottom of the next step. 1 minute is 60 seconds. Hours cancel out, minutes cancel out. Type it into your calculator. What just happened here? Something weird. So I'm going to type in 1.32 times 60 times 60. It's all ones on the bottom. What did I do? 1.32 times 60 times 60. And I got 4,752 seconds. But I only need 3 sig digs. So 4,752 is going to round to 4,750 seconds. So that is how you do it. What about how many minutes in 1 year? Oh, I should probably say 1.000 years. How many minutes in 1.00 years? I would suggest pausing it at this point and trying this one on your own. Okay, here we go. Starting with 1 year. I know that 1 year on the bottom is 365 days. Now, sometimes you'll be given that like 1 year is 365 and a quarter days. If you are given that, if you're given that conversion factor, use that. But I'm just doing this for my example. And I have 1 day in the bottom because I have days on the top. 1 day is 24 hours. And I know that 1 hour is 60 minutes. If you are a fan of Rent, oh shoot, I should have written this as 1.000. That's really important because that tells us it's 4 sig digs. If you are a fan of Rent, you probably already knew this answer because the answer is this. 525,600 minutes. How do you measure a year? It's all about love, 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 love. Yeah, you guys have heard that before, right? 525,600 minutes. So there is that. Okay, let's do another one. What if we're going from metric to English? If I am going from metric to standard, the key for this is the following conversion. You must know that there is 2.54 centimeters in 1 inch. All right, you've got to know that. This is the conversion that we use in science to go from standard to metric or metric to standard. So if I said, how many, let's do millimeters, are in 2.2 miles? How many millimeters in 2.2 miles? So I'm going to start out with, let's do 2.22 miles, just to give us 3 sig digs. 2.22 miles. So if I have 2.22 miles, I'm going to go with my 1 mile is 5,280 feet. Feet on the top, so feet on the bottom of the next step. So 1 foot is 12 inches. And here it comes. 1 inch is 2.54 centimeters. And there, in 1 centimeter, there are 10 millimeters. You could also say that there's 0.01 centimeters in a millimeter. However you want to do it, it doesn't matter. But in 1 centimeter, there are 10 millimeters. My answer should have 3 sig digs. So I'm going to multiply 2.22 times 5280 times 12 times 2.54 times 10. I've got a big number. I can only have 3 sig digs, so I'm going to have to put this into scientific notation or have a bunch of zeros. Put it in scientific notation though. So this gives me 3.57 times 10 to the 6 millimeters. Also think about your answers and figure out if they make sense. All right? I'm going from miles to millimeters, so this should be a massive number. But at this point, we haven't divided by anything on the bottom because these have all just been 1 dimension. They've all been over 1. What if they're not? What if we said, how many meters per second are in 25 miles per hour? 25 miles per hour. So the first thing you need to do is know how to set this up. So I'm going to start this out as literally 25 miles over 1 hour. That's how you have to set this up. And the first thing I'm going to do is I'm going to get miles to meters. So I have miles on the top. And also, some people like to set it up like this, so I'll do this one like this, just to keep their work a little bit neater. So I know that 1 mile is 5,280 feet. All right? And I know that 1 foot has 12 inches. And I know that 1 inch is 2.54 centimeters. And I know that there are 100 centimeters in 1 meter. Oh snap, we have something on the bottom. At this point, miles cancels, feet cancels, inches cancels, centimeters canceled. I've got meters, so I have meters on the top, but now I need to get seconds on the bottom. This is the beauty of dimensional analysis. You can do it all as 1 step. So if I have hours on the bottom, I need to have hours on the top of the next step. So 1 hour is 60 minutes. And I also know that 1 minute, now that I have minutes on the bottom, I have to have minutes on the top. I know that 1 minute is 60 seconds. Hours here, cancel out hours here, minutes here, cancel out minutes here, leaving me meters over seconds. So multiply this out on your own and see what you get. So maybe take a quick pause, multiply everything on the top, divide by everything on the bottom, and see what you get. Okay, so here's how I would type this in. I would do 25 times, 25 times 5280 times 12 times 2.54 equals, divided by, there's a couple ways to do this. You could do parentheses, 100 times 60 times 60. I just like to do it divided by 100 equals divided by 60 equals divided by 60 equals. You'll get the same thing either way. However you want to do that, just make sure you're following order of operations. I'm starting out with 2 sig digs, so I have to end with 2 sig digs. So my answer is 11 meters per second. 11 meters per second. So that's a double dimension. I think probably the hardest one you'd have to do in CP Chem would be something with density or a rate. So the one I'd like to do is the sun is 93 million miles from Earth. This was the first $1 million question on Who Wants to Be a Millionaire. If you ever saw the original Who Wants to Be a Millionaire, they had 3 lifelines. It was phone a friend, 50-50, and poll the audience, ask the audience. Well, this guy I don't think he had used any of his lifelines. And he calls, and the question was, how many miles is the sun from the Earth? So he calls his dad. He's like, I need to phone a friend. And this is in the $1 million question. So he calls his dad. He's like, hey, Dad, just want to let you know I'm about to win $1 million. I already know the answer. And the whole audience goes wild. And it's Regis. It's an old talk show guy. I don't know if you guys know who Regis Philbin is. And everyone's just like looking. It's awesome. He's like, 93 million miles, and he wins $1 million. But yeah, he used his phone a friend to call his dad and tell him that he was going to win, which is pretty epic. Anyways, and this is what I do. I get way off track. The sun is 93 million miles from Earth. Light travels at 3.00 times 10 to the 8th meters per second. At 3.00 times 10 to the 8th meters per second. So I could ask you, how many minutes does it take for light to reach, there's an E in there. How many minutes does it take for light to reach Earth? This is where we're going to save the rate. Save the rate, save the rate, save the rate. This is going to be our conversion factor that we're going to have to use later to convert between one thing and something else. So on this one, I'm going to start out with my 93 million miles. So I've got 93 million miles on the top. And I know in order to get this to minutes, I know I'm going to have to get it to meters, because meters will let me get to seconds. So I need to get miles to meters first. You'll see in a second what I'm talking about. So I know that 1 mile. So you guys can decide if you like this version or my version. I don't think Salvadio's going to care. 1 mile is 5,280 feet. And I know that 1 foot has 12 inches. And I know that 1 inch is 2.54 centimeters. And I know that there are 100 centimeters in 1 meter. This is where my rate comes in. This is now what I'm going to use. This is why I saved the rate. So I know If I have meters on the top, I have to have meters on the bottom of the next step. So I have 3.00 times 10 to the 8th meters for every 1 second. That's why you save the rate. You save the rate to get to the desired unit you want. I want to get it to minutes though. So I know that there are 60 seconds in 1 minute. Everything should cancel out. Mile, mile, feet, feet, inch, inch, centimeter, centimeter, meter, meter, second, seconds. Leave me minutes. And that is why units are a breadcrumb trail. So multiply it out. I don't know what the answer is. I think it's like 12 something, 8 or 12, something like that. So 93 million times 5280 times 12 times 2.54 equals, big number, divided by 100 equals, in order to do scientific method in your calculator, I use the EE button. So I divided it by the 100. I'm going to show you how to do the EE. So what I like to do is divided by 3 second EE8. When you do it like that, it does order of operations for you. Equals, I still have to divide it by 60, divided by 60, equals, look at that. I started out with 2 sig digs. I have to end with 2 sig digs. So my answer is 8.3 minutes. My answer is 8.3 minutes. So if the sun explodes, we will not know until 8.3 minutes later. And that's a real downer way to end the notes. So let's be happy that we have the sun. And it's a beautiful thing, and it's fairly stable. It's a main sequence star. And that is a pretty dang good intro on dimensional analysis. Hopefully this helps. Good luck the rest of the week. And Yahtzee.